So I've been standing here for a while staring at these things and taking some measurements, trying to figure out how to get this electric motor from a smart car attached to this transmission from a 1950s Jeep. For those of you who may not have been following this project, I'll do a quick recap. A friend of mine said if I dragged this Jeep out of his woods, I could have it. I stripped it all the way down to the axles and spent the past 20 months rebuilding it with the goal of converting it to an electric vehicle. Now that I've rebuilt the body, it's finally time to get working on the drivetrain. First thing I want to do is figure out an adapter plate to adapt this bolt pattern to that bolt pattern, but I also need to take into account how much this bearing is going to stick out, but I can measure that off of the bearing retainer. I also need to account for this little spigot on the motor. I'm also planning on cutting down an input shaft and cutting new splines in it to match the splines on the motor, but I've also got to figure out how far in I can come with the cutter to cut the full depth of the spline before I run into the shoulder for the bearing. And it also turns out that the bore for the bearing in the transmission isn't centered to the bolt pattern on the transmission. And while these bolts are all on the same bolt circle, none of them are the same distance apart. It took me a couple tries to get measurements that would actually come somewhat close to closing. Now the laser cutter's doing its thing. Let's see if I can get this O-ring off in a manner that I'm not going to get comments about being some sort of animal about it. Probably not. I guess I'm at least some sort of advanced animal. I still haven't dialed in how much clearance to leave on bores on the laser cutter. The center bore is actually going to locate this. These bolt holes just need to be close enough to get within the clearance. Seems pretty good. The one on the transmission is not quite as good. For one thing, these are supposed to be 7/16 holes instead of 3/8. And it looks like this hole could shift down a little bit. That should work. Pretty good confirmation of the bolt patterns now. Now, a mostly normal person would probably just buy a big slab of aluminum and drill and bore the necessary holes in it and be done with it, and that would be easier. But I don't like to do things the easy way. I like doing them in the way that gives the most satisfying result. So I spent a while drawing up a pattern in CAD so I can cast this thing into the most satisfying shape possible. I cut the outline of this into the spoil board just so that I could line it up when I flipped it. And naturally I don't have a flask big enough for this either, so I need to make one of those. Maybe not that big. So obviously my first attempt at ramming this up didn't work, and neither did my second. The third one I added some machine screws and washers, made it a little better. So this time I flipped the whole thing over, picked the cope up. Of course that broke out. I mean, I keep getting closer, right? This time I swapped over to some sheet metal screws, and the bottom half came out really nice, but the top half broke out a lot. This one's not great, but it's the best one yet, and I think I'm going to go with it. This, well, it kind of just became a core piece now. So what am I going to make this thing out of? Got some parts from a snowmobile clutch, the thermostat housing from the Jeep, oil pump from something. That was for holding like oxygen tanks in an ambulance. And the circular saw that was in the back of the Jeep. Let me go smash this stuff up. This pour went poorly. I couldn't get anything to go down the sprue, so last-ditch effort I poured it down the riser hole, which is really the worst possible way to do it. Well, that obviously went poorly. It didn't really take the metal. It came down the sprue, which is up here, and I had kind of choked off my gates to try to minimize turbulence and porosity and all that. But I was also pouring cold to try to minimize shrinkage in the middle, and that was a bad combination. So, we'll try it again. This one didn't really go a whole lot better. So the post-mortem on this one, the sprue choked off before the metal ever even reached the bottom. Looks like there was a chunk of sand in there or something. I also had way too much moisture in the sand, so we got a lot of steam bubbling up through. And I just didn't have enough aluminum melted. It didn't totally fill in there. It just kind of bubbled up and made it look like it's solid, but it's really not. For the third attempt, I resorted to a technique that I usually find ensures a high rate of success, which is to just not video what I'm doing. This one came out pretty well. Couldn't get a good angle with the bandsaw to cut the riser off, so I resorted to the hacksaw. I find that the needle scaler does a really good job of evening out all of the grind marks and file marks, leaving a nice even texture. And then I stuffed this thing on the shelf for several months before getting around to making the tooling I need to finish it. It's within like 3 or 4 thousandths that way. One of the problems with working with a casting like this is finding a reference to get it square. Best thing I have is kind of working off of these two corners, or these two. They should be parallel. If I use those, I should be able to square it up pretty well. Just going to use that as a weight to keep that in place. As a sanity check, we'll do the other side as well. Got this side lined up there. I more or less just split the difference here. It's not going to be exact, but that's kind of the nature of castings. I got very roughly centered up on the bore here because it's very rough. I'm going to rough bore this mostly so I have a reference for when I flip it over, and also just to establish a 0 point. This hole will eventually get bored out for this bearing. I'm going to do that from the other side just so I can keep things concentric. But since this piece is also functioning as this bearing cap, it needs a little counter bore for the snap ring. That doesn't really need to be all that concentric, so I'm just going to go ahead and do that now. I want to do the mounting holes next. Since that's my 0, I can go back to my CAD drawing and find those locations. I'm going to spot them all first, make sure that they land somewhere that makes sense. That doesn't look right. It should be 6 1/4. I'm at 6 1/4, so 6 1/50 instead of 6 2/50. Kind of agrees with that. Where am I off? Nope, that looks right there. And actually, if it needed to go that way, then this gap would be bigger. So maybe that's wrong? I forgot to take the backlash out. There are 3 threaded holes here that would hold this bearing cap on. Figure I might as well utilize those too. They don't seem to be evenly spaced at all, so rather than trying to measure them and work out where they actually sit, I'm just going to transfer the holes to my template. Of course, I don't have the proper transfer screws, so I'm just going to use some set screws. I'm just putting in clearance holes, so they don't have to be super precise. Now I'm just going to visually line these up. I drilled through the wood just far enough to mark the part, and then double checked on the transmission again. I made notes of all of my dial readings for each point so I can pick them up again. I went back to the CAD and tried to work out with the distance between the holes and all of that angles or dimensions that work out right to make sense when this was originally made. and I can't figure it out, so I'm just going to drill them where they transferred. Worst case scenario is I'll have to open up the clearance holes a little bit on final assembly, but I'm not too worried about that. I think that wraps up everything on this side, so it's test fit time. Well, that fits so far, and man, that's a thing of beauty. So I've got 4 of these held down with 3/8 screws. This one's drilled for 5/8. That one's not doing anything because there's a massive hole in my table. I've still got the spindle directly over the T-slot, so now I just need to line these up. This one's not over T-slot, so I'm going to drill and tap it. Countersunk these two just so I can put some screws in, make sure everything's really good and tight, and then fly cut the whole thing. Well, now I've got a nice flat fixture there. I know somebody's going to say that I need to trim my mill to get rid of these lines, but there's no knot adjustment on this mill. That's just wear in it. The saddle is definitely kind of concave. And in terms of the left to right tram, again, there's so much wear that somewhere along the travel it's actually right. It's as good as the old girl's going to do. I want to just pull this thing off, make sure there are no chips underneath it. Before I move on, I want to do a little inspection, which means I need to dig out my surface plate. I know it's not a good idea to set things on your surface plate when you're not using it, and since I know I'm going to do that, I made this cover for it. So I end up putting a lot of things on my surface plate. I'm going to go ahead and use my comically large indicator for this. Hopefully that way you guys can see it, but I'll make sure that it's either overexposed or out of focus. So after a bunch more inspection with both comically large and reasonably sized indicators, I've kind of come up with figuring out that this corner might be a little bit low, maybe 1/1000th, but it gets up to about the same height here, and then the rest of it is probably within 1/2 a thousandth. maybe a thousandth. Really what I determined was I need a better surface gauge. The other question, of course, is how good does it need to be? And the answer to that is I'm not exactly sure, but I think that's pretty good, and it's certainly as good as I'm going to get it, so I'm going to go with it. I did go back and manage to find a spec for a 6208 ball bearing like the one on the front of the transmission. It said it could tolerate 8 minutes of misalignment. Doing the math from the center of the bore to the corner, that works out to about 10 thousandths, which seems like a heck of a lot to me. Anyway, I'm going to get the bore centered and work on making it bigger. I am just trying to sneak up on this little by little. These little snap gauges can be kind of tough to get real accurate results with, but the one thing that does give you an accurate result is a go, no-go gauge like the bearing that actually is supposed to fit in here. I think that's a go. Well, that says I'm on dimension. Yep, it's on dimension. Of course, I can't get this far enough back to get to that last hole. First, you just turn it a little bit, clamp it differently, and everything works out. So I put this thing on the transmission, and I put the input shaft in, so I can kind of explain why I'm doing it this way. The smaller bore here locates the plate onto the bearing, and the larger bore locates the motor onto the plate. Really what that means is that the plate is aligning everything to the shaft. So it's important that these two bores are concentric, and the best way to ensure that they're concentric is to machine them in one setup, which is what I did. But I also need something in here that's going to push the front of the bearing back and kind of pinch that snap ring between the front of the transmission and the bearing. There's also an oil hole in the input shaft that I'm using, which means I'm going to need an oil seal on the front here. What I'm going to do is turn another piece that's going to press into this bore, push the front of the bearing back, and give a seat for that oil seal. I don't have the appropriate size piece of round stock, so I'm going to make one. I've got this one, which is almost right, but it's about 20 thousandths under, but we're just not going to talk about that. The final thickness of this is only about 60 thousandth or 1.5 millimeters less than the raw stock, so I'm machining a little step to hold it by. I'll face most of this off after I turn the OD and IDs. There will be a little bit of the step left, but it won't affect the function of the part. came out as a really nice slip fit, but I wanted it to be a press fit, so a little Loctite 680 in there. Of course, I don't really want that glued onto the bearing or the front of the transmission, so I'm going to pull it off before it cures. Now that that's set up, there's one last thing to do, and that's address this hole, which I was trying to figure out what it is. Then I looked at this. It's an oil return hole so that the oil that does get out to that seal can get back into the transmission. So I just need to add a little feature like that. I guess the thing to do now is to put it all together. There is supposed to be this O-ring on the snout of the motor, which sits in here. Obviously that's not going to do anything this way. I'll probably just goop this up with some RTV when I do final assembly. I know some people aren't into the EV conversion thing, don't like the idea, but it's hard to argue that that's not incredibly well packaged. I'm really happy with how that came out. Of course, since the internals aren't connected, it doesn't actually do anything, but it does look good. So in other words, it's totally ready to take to SEMA. Not that I'm going to SEMA. And I'll get this input shaft sorted out next time, so if you want to see that, stick around. While we're here, and since you asked, I figured I'd answer some of your questions about this. First, do I actually need a transmission? I don't need a transmission, but I need a gear reduction. Typically an EV will have a final drive ratio of somewhere between 8 and 10 to 1. Second gear on the T90A is 1.55. Multiply that by the 5/3/8 in the differentials, and I come up with 8.34. So most of the time I'll probably just leave it in second gear, but I will also have first and third for times when I want to go faster or slower. Shouldn't I have the coolant ports clocked up to the top? So I based this off of sort of the best pictures and diagrams I could find of the drive unit in the smart car. And as you can see, it's not the top. The issue becomes if I rotate the motor any more, the wiring connectors drop down further, which would expose them more. So I'm sort of compromising here. Hindsight being what it is. If I did this again, I'd probably leave a full flange on here just so I can adjust how the motor's clocked in a little bit more. But since it's a Jeep, worst case is I just drive one side up on a big rock and bleed the air out of it that way. Couldn't I just use low range in the transfer case? Yes, but I don't think the motor would fit very well. And the low range gears on this transfer case are straight cut, so it would be really noisy. Why are you doing all this work on the Jeep only to ruin it by converting it to electric? Because I want to. I made a whole video on that.